This video is the 8th of a series of tutorials discussing the LX7720 radiation-hardened motor driver for space. First, here's a reminder of what the LX7720 is. The LX7720 is a mixed-signal peripheral which works with an FPGA or a microcontroller to build a complete closed-loop brushless DC motor controller or stepper motor system. The first two videos outlined the LX7720 at a system level, and then dived into a detailed discussion of the half-bridge FET drivers. Videos 3 and 4 introduced the LX7720's 4 current sense amplifiers and showed how to use a current sense amplifier in each of the 3 common current measurement topologies used with motors. Video 5 discussed separating a half-bridge into independent low-side and high-side drivers, and how to use current sensing in these cases. Videos 6 and 7 discussed connecting an LX7720 to brushless DC motors and bipolar stepper motors. This video will discuss connecting an LX7720 to unipolar stepper motors. The LX7720 contains 4 half-bridge driver stages and 4 current sense amplifiers, which is enough to drive 2 two-phase unipolar stepper motors with full current sensing. One motor uses the 4 high-side drivers and 2 current sense amplifiers. The other motor uses the 4 low-side drivers and the 2 remaining current sense amplifiers. Here's a generic 2-phase unipolar stepper motor being driven by 4 low-side drivers operating in pairs. The LX7720 circuitry is shown simplified, with supplies and decoupling to the current sense and gate drive sections omitted. The key components are the 4 half-bridges and the current sensing. Each low-side driver pair has current sensing in one of its half-bridge outputs. Since only one half of each unipolar winding is powered at a time, only 2 current senses are needed for full motor winding current measurement. In this example, the 2 unused current sense amplifiers are shown disabled. Also, the LX7720's 2 grounds, S ground and M ground, are joined together directly on the PCB. Please watch the 6th video for a detailed discussion of the LX7720's S ground and M ground ground domains. The motor winding's center taps are connected to the motor supply, V motor. Since V motor has no connection to the LX7720, this voltage can be different to the LX7720's normal VMPS motor supply, if desired. Motor winding currents flow in from V motor through half a phase winding and out to the motor ground, M ground, through a low-side FET and the current sense resistor shared by each phase winding. Diodes in parallel with each winding are necessary to recirculate winding current when a driver FET switches off. Here's the alternative configuration for a 2-phase unipolar stepper motor, now being driven by 4 high-side drivers instead of by 4 low-side drivers. Since the high-side drivers are used, the motor supply must be the LX7720's normal 20-volt to 60-volt VMPS motor supply. As before, the 2 unused current sense amplifiers are shown disabled. The motor winding's center taps are shown connecting to a power ground connection called P ground. Ideally, P ground should return to the driver board via a dedicated conductor to terminate at M ground. In that case, the LX7720's 2 grounds, S ground and M ground, are joined together directly on the PCB. For situations where the P ground power motor ground will be terminated elsewhere, see the discussion about the LX7720's S ground and M ground ground domains in the 6th video. Motor winding currents flow in from the motor supply VMPS through a current sense resistor shared for each phase winding, then through a high-side FET to a half-phase winding, and finally out to the motor ground. As mentioned at the beginning, a single LX7720 can drive 2 unipolar stepper motors with full current sensing using these 2 configurations. An LX7720 provides 4 low-side drivers, 4 high-side drivers, and 4 current sense amplifiers. That's exactly the resources required for a dual unipolar stepper motor driver. As a reminder, one motor must operate in the LX7720's allowed 20 volt to 60 volt supply range, while the other motor can operate from any voltage, higher or lower.